formulas express relationship between two or more variables. They are used to common or many common situations from geometry, from everyday world. But companies use for more sophisticated models. Okay, so mathematical modeling is the process of finding formulas to describe real-world phenomena. Like if you drop off a weight, how fast it falls. If a car travels at a certain speed and hits something, how long does it take to slow down, completely stop? Also, a bullet, for ballistic measurement. If they fire a bullet at some sort of block, they want to know how long it takes to slow down or stop the bullet. All that can be obtained or modeled using formulas, physical situations that do have some everyday use. Like if you want to know if your bulletproof vest is effective, you have to know how much impact it can absorb before failing. And that's a model using very sophisticated physical models, which we're not get into. We will look at very simple things like something like that. Now, let's look at parts of the algebraic expression. Right? Some vocabulary of algebraic expression. If you see the word term, what does this mean? Well, it is the part that is separated by a plus or minus sign. Those parts separated by the algebraic expression. Separated by distance or write any subtraction in terms of position. My is what? It is A plus A is B. Now, what is the coefficient? The coefficient of the term, the coefficient is the factor, numerical factor of part of the term. What is the numerical factor, or numerical part? Multiplying the variable. How about for -9y? What is the
-9.
yeah. How about for -3?
-3.
That's what's up. If you have a part that has no variable, that's called a constant. So, constant part. That's just a different number. There's no variable. So if you look at these three parts, this one is a constant. It's only the -3 that's a constant. All the others have variables involved. And what I call like terms. Like terms are expressions that have the same exact variable, right? Terms that have the same exact variable. And this will be important when it comes to solving equations. What we want to do is to combine together like terms. So, for example here, we have, let's say, 7x and minus 3x. And they have same variables are like terms. These are like terms, but they have the same variable.
Aren't you missing a word in the definition? Terms that the same exact variable.
do not like curves. Even if they have the same variables, these variables not the same power. Right? The axis, the first power here, while the axis, the second power here. So they're not the same, not like curves. If you have, let's say, x, y, z, and x, y, these do not like curves. They don't have the same power and the same variable. You will see why like curves are important later on when we look at trying to solve equations. Okay. Understand what we mean by like curves.
Yes.
Okay. Now, another last term, factors. What do we mean by factors? These are part of each term that are multiplied together. So, for example, in some that, what are the factors?
Seven or X.
There's a 7 and x. 7 times x will give us 7x. How about in negative 7 x squared y? What are the factors here?
7X and Y.
Essentially,
Oh, negative 7. Sorry.
in negative 7 x squared and y are the factors. What is this negative 7x squared y? We can write it as negative 7 times x squared times y. Generally, we don't write the multiplication sign between variables. If you see a number next to a variable, it simply means multiply. How about something like this? X over 2. What are the factors here?
X and 3.
X over 2 is not a factor. How would we write this? This is essentially 1/2 times x. That's what x over 2 really means. It's 1/2 times x. So what are the factors here? Factors are 1/2 and x. Right? Most of the expressions that they multiply together. divided by b is just a times the reciprocal of b. That's how you want to think of division. Now, if you know the sign rule for multiplication, you then know the sign rule for division. Yeah. Now, let's look at some properties of the real number system. What is the real number system? Well, it involves all the integers and the fractions. Right? It involves a number like 5 and many other numbers. In fact, there are more real numbers than there are integers. We can actually count the integers in a sense, so we can't really count the real numbers. They are too numerous. So that what is the properties of the real number system, and certainly also the integer. These are the properties that you want to keep in mind. You've seen some of these before. We need these properties when we want to solve equations. Commutative. We can change the order of the addition, and it doesn't change the result. A plus B is the same as B plus L. So, for example, let's say we have x squared plus 7. Right? So 7x. This is the same as 7x plus x squared. It seems obvious that this is true, but it's not obvious. To try to prove something like this, it involves a lot of math. It just proves that you can switch the order around. But that's what we observe in the integers. You can switch the order of addition around. You cannot switch the order of subtraction around.
Because it matters which one is first.
Yeah. Right. So you can always switch addition around the order. You can also switch the order of multiplication around. Multiplication. associative operator. What does this mean? Well, you can add A to B first, then add F to C. Alright? It's the same as adding B to C first, and then add that to A. This allows us to change the way in which we group things. One operation may be easier than the other. Right? If this operation is easier, then this is probably a better way to do the calculation. In terms of variables, say we have 3 plus 8 plus X here. All right? What will the associative property allow us to do? We can change the grouping. We add 3 with 8 first, and then add that to X. What do we get then if 3 plus 8 is the denominator plus X? So by using this property, we can change the order of grouping any way we want so that we can simplify this question. Alright? So by using the associative property, instead of adding 8 to X first, we add 3 to 8, and then we simplify. Alright? This is not true for subtraction. You cannot just group things arbitrarily with subtraction. With addition you can, and also with multiplication. Associative associativity multiplication. You can change the order in which you multiply.
What is X?
It's all for the variable. Same thing. Solving the equation. And that involves return all values of that. And applying all values of that. That result in a truth statement. When it is substituted into the equation. And that's what we want to do now. Right? This is, and such solutions are called root of equation. Its values are solutions of the equation. In other words, are root. Now, one thing to keep in mind with equality. So let's say we have A equals B. If we add the same thing to both sides, we will still have equality. Right? So if this is true, then we can add the same quantity to both sides. Right? So if we add the same to both sides, we have not changed the equality. It's still equality. Both sides are still equal. Right? Where C is a real number. You want to think of it as if you have a balance and you add the same amount to both sides, you haven't really unbalanced the equation. Also, you can subtract the same thing. If A equals B, then this is true, and you can subtract the same amount from both sides. Take away the same amount from both sides, you have not changed equality.
Okay.
Now, the same thing applies for multiplication. If A is equal to B, then 10 times A is 10 times B. You haven't changed the equation. So basically, if this is true, then you can have this being true, this being true, and also A times C is the same as B times C. Both sides of equal size, that's changed by multiplying by the same number. same for a division. A divided by C is the same as B divided by C for C greater than 0. So you can divide by the same number and not change the quantity. So by using these properties here, all these properties here and these properties, you can then solve for these equation. Right? So what's the process? Well, you want to simplify both sides of the equation by removing any parentheses. This involves often using distributive properties. Right? You have to get rid of any grouping symbol as much as possible. And then what? Well, you want to get the variable by itself. You want to isolate the variable. So that involves either adding or subtracting to get the variable term by itself. And then you may have to multiply or divide to get rid of the coefficient in front of the variable. To get the variable by itself. All right? So what is the process of solving the equation? It can simplify, and here's the process. I'll give you in detail and give you many examples. And here's the step in solving a linear equation. Notice that we're looking at one particular type of equation, a linear equation. Because the steps that are involved in higher power equation is more complicated. A linear equation means that all the variables are to the first power. So, something like this is not a linear equation because you have
A second power.
Right? Something like this is a linear equation, right? Because the highest power is the first. Yeah. So what we want to look at is solving linear equations. The highest power is the first power. Alright, so what is the process here is to simplify both sides of the equation. If there are any parentheses, simplify the algebraic expression. On each side. And by removing parentheses, the grouping symbol. Okay. And combining like terms. So we have to know what we mean by like terms. And that's why I defined it for you earlier. Okay. They are expressions that have the same variable to the same power. Okay. Now, what do we do after this? Well, basically collect all the variables Then, well, it's in the next step, well, isolate the variable term. Isolate the variable. Once you isolate the variable, you just have to solve the equation. But of course, you may have made a mistake somewhere, so the last step is to check. Check the proposed solution. In the original equation. Basically, you want to use the original equation because you may have made a mistake somewhere in the subsequent equation. So you use the original one, you can check to see if the solution is correct or not. When solving these equations, you make it one solution, or you make it no solution. There's nothing that guarantees that an equation has a root, has a solution. It may be impossible to solve it, or you make it infinite many solutions. Essentially, you have something that's an identity that's always true. No matter what you would get for the variable, it will always be true. Right? So, say we want to solve this equation here. So we have an algebraic expression separated by equal sign, an equation. What we want to find the value of x that will make both sides true. How would we do it? Well, the first step is to get rid of the parentheses. Use the distributive law. We multiply through 3 times x minus 3 times 2. Alright? So the distributive color. We got rid of the parentheses. Now, what do we end up with? We have 3x minus 6 equals 4 plus x. Now, how do we collect the variables together? Now, what we have to do is to bring this x over to the other side. Right? No. No. Yeah. Right. How would you get
You
rid
can't
of the
remove
plus
anything
x?
if you don't subtract.
You have to cancel it.
Yeah.
You
So
have to cancel
subtraction
this
is
x. So you can take away x from both sides. Whatever you do to one side, you have to do to
the other.
both sides. So that you have equality. Okay. Totally. Right? Basically, if you want to remove this x here, you have to take away x, right? You have to undo the addition, so you have to subtract away the x on both sides. Now, what do we get back? What's 3x minus x? These are like terms. So yeah, we'll get 2x minus 6 is equal to 4. Now, what we have to isolate this variable. So how do we get rid of this
You
6?
add
Yeah, we add 6 to both sides. Right, and what do we end up with? We end up with
2x equals
equal to 10. All right, so now, how do we get the variable by itself? How do we isolate it?
you divide
Yeah, we undo
the multiplication.
2 by dividing by 2. We divide both sides by 2, and we
Get
get
5.
x is equal to 5. This is the proposed solution. Right, so we've got to step 3 here, but we don't really know if that is the solution unless we check.
You have to put 5 in place of the x in the
Right.
equation.
So in the original equation, we put 5 into here and see if both sides will be true or not. So 3x minus 2. Right,
No, you gotta put 5, yeah. And 4 plus 5.
So, yes, we have 3 times 5 minus 2. Is this equal to 4 plus 5? Well, we have 3 times
3.
what's 3, okay? And
9.
we have 9 over here. And yes,
3
3
times
times 3
3
is
is 9.
equal to 9. That's how you do the check. So you have to use the original equation. You have to do the order operation right. Then you get the answer. That you have a true statement. So 3 times 3 does equal to 9. Any question with that?
No.
Alright. So that's the process of solving a linear equation. The highest power is 1. Okay. Let's look at some more examples here. Let's say we have 3x minus 4 is equal to 5x plus 8. Alright, so how would you solve something like that? Basically, what we would write is the solution set over here. The solution set is just one number, 5. Alright. How would we solve something like that? Well, since there are no parentheses, you just have to try to bring the x together, the x terms together. It doesn't matter which side you bring it together. You can bring the 5x over, or you bring the 3x over. It doesn't really matter. Right? I would bring the 3x over to the other side, so I take away 3x on both sides. What do I end up with for the left-hand side?
Negative 4.
Yeah, negative 4 is equal to
2x plus 8.
plus 8. All right, and then I would bring the 8 to the other side. And subtract 8, right? I want to get 2x by itself. So what we end up with here is negative 12 is equal to 2x. What would be, how would we solve for x here?
You divide.
Yeah, we divide both sides here by 2.
It's negative 6.
Negative 6 is equal to x, or x is equal to negative 6. All right, then what you have to do, you have to
You
check.
have to check it.
Right. So, check what is the equation. What is the solution, the proposed solution?
So it would be 3
check here.
times negative 6 minus 4. Oh,
So
equals
it's
5
-6.
times
Is
negative
this equal
6
to 5 times -6
plus 8.
So what's 3 times -6? -18. How about what's 5 times -6? -30.
30.
Alright, now you have to do the addition here of -18 with -4. What do we end up with? This is -22, and is this equal to, yeah, -30 plus 8 is -22. Both sides are equal.
So fun.
Your sarcasm is very overwhelming.
Right, well, control the following. Solve this equation.
Yes.
Group work, guys.
So,
I don't know. We give you a worksheet. I'm trying to kill you with math.
clearly, we can see that.
No, this is a different thing.
No.
Well, one way to check is
So
to
put
guess
one
and put
in.
it in and see.
I said that.
Give me 5 minutes.
It's okay. We listen and we don't judge. I judge, but you know. neither here nor there.
One way to solve an equation is to guess.
He's joking.
Sometimes
He's joking.
He only could be and guess the right one. But that's only for a very simple equation like this. Or someone, for something involving second or third power, guessing like if you know where.
His sarcasm is also unmatched.
Alright.
And I'm just sitting here snacking.
I'm just looking at you eating.
Yeah, I'm not gonna lie, sometimes, like in a lecture class, like the consistent sound of the professor's voice, it be like, go to sleep, girl. So I gotta eat to stay up.
You get whole numbers when you solve the equation. You'd be lucky to get a whole number most of the time. Some of them can be fractions. You pointed at that one instead of fractions.
Damn.
That's it. Take it or leave it. In the real world, do you always end up with whole numbers?
Those.
No.
Damn, Pop, you made me write 3 pages worth of notes.
What do we have here is 2x plus 2 equal to 6x.
Yes.
Right?
So now you're gonna subtract two. Subtract 2x
from
on both sides.
What do we end up with?
You end up with 2 equals 4x. Now you're gonna divide by 2. I mean, yeah.
Yeah, we divide by 4.
I'm sorry, yeah, 4.
Right? And you end up with a fraction, essentially. What do we have is that x is equal
X is
to
to 1/2.
1/2. Right? Now, how will we check that?
Insert 1/2 into the equation.
Right? So in check, what you do is you put 1/2 into x. Right? Is this equal to 6 times 1/2? Well, now you can add these together if you want, or you can use the distributive to get rid of the parentheses.
Yeah, you're gonna distribute
2 times 1/2
plus
2
2.
times 1. Now, what is 6 times 1/2?
3.
6 over 2. Now, what's 2 times 1/2?
The whole.
Yeah, 1 plus 2. So is this equal to?
Yes.
3. Yeah. 6 divided by 2 is
3. Yeah. What did you get?
Nothing was I didn't do it.
Yeah.
Right.
It's okay to be
Did you
wrong.
say x is 1? So look, if you guess that x is 1 and verify it.
Now I know how to do it.
So you
Yeah,
guess
pay
x is
attention.
1. Check this. Will it give you true statement? It doesn't, right? If you put 1 into here, what do you end up with?
Okay, give us another one here. Thanks, you for not helping.
Well, you end up 4 on one side and 6 on the other. So this cannot be.
Yeah, that cannot be true.
Right?
It doesn't check.
Yes, it doesn't check. And this is 2 times 2, which is not 6. So both sides are not equal. So x equals to 1 is not a root.
Read.
Any question about? What was the other example I gave there? Oh, race book.
The other example. Oh, yeah, you did. I didn't write it down, sorry.
Which one was it?
It's not on your paper?
5x minus 9.
Yes, the last one. Yeah, you're gonna crash out, so you gotta do your sheet for homework.
Right, so solve that equation. Solve 5x minus 9 equals 6x plus 1.
Are you making this up as you go? The fact that you can make this up in your head backwards and write it out at the same time is crazy.
The next question is gonna be like confusing. Actually, everything is gonna be like this.
You need me to follow the people too.
No.
Hmm.
Say that.
No, I'm joking.
Tell me what you will do with that.
No. I'll be honest.
What do people get for this third one here?
You want the answer or it's negative 10?
Negative 10.
The check answer is negative 59. So you're gonna subtract 5x from both sides. And then you're gonna have negative 9 equals 1x plus 1. Yeah.
So we have negative 10 equals x, or since the x is negative 10.
Yeah.
Alright, now you can check it if you want.
If you check it, it's negative 59 equals negative 59.
Alright, so what do we have here for this one?
Some hard problem that you want us to figure out. Hmm?
Yeah? Now what does that tell you?
What does it tell you? Nothing.
And then you have to think about it. What does it mean?
I don't like guessing. It's not a sure way.
It means nothing.
Nothing from nothing leaves nothing.
What does it mean to solve an equation?
To have an answer?
So define all the values of the variable that makes both sides true. That gives you a true statement. All right. When you multiply it out, what do you get? Negative 3x minus 6. All right, now let's add the like terms together. What do we have? Negative 6 minus 3x. All right, now let's get rid of the 6.
Alright, I didn't do that. Yeah. Let's see what this answer is.
Yes, x is equal to x. What does that tell you?
I don't like this question. Yeah, because I got 1. Is it 1? No, or is that the answer?
It means that no matter what x is, you have both sides being equal.
So we don't know what x is, but we know x is equal to x.
Yeah.
I don't like that.
There are infinite solutions to that. It means what? Any value x will solve this equation. Well, you have to understand what it means to solve the equation. You try to find the values of x
And I guess that
that
does
make
make
both
sense.
sides true. When you get to something like this is always true, regardless of what x is. Right? So, what are the possible values of x? Any number that you want. This has infinite many solutions.
Hold on, wait. What?
That's the end of your question, is what?
You want to continue this? Yeah, go
No, we
ahead.
don't wanna continue, we wanna restart it.
You have 0, you go to 0.
So instead of having,
What does
minus
this
2
tell
and
you?
minus 4 on the same side, if you combine it, it's gonna give you minus 6. So instead of having 2 subtractions on one side, he brought it down to make it 1, so that the problem is the same on both sides. You understand?
Okay.
When you get to here, you have something that's always true. 0 is equal to 0. So that tells you what? That the equation that you have, you started with, if you did everything correctly, is both sides will always be equal to each other.
No, he didn't subtract the 2 on both sides. When he distributed the -3, he was gonna end up with 3x minus 6, right? Because it's a negative times a positive. On the opposite side, there's a -2 and a -4. Instead of leaving it to be 2 separate equations, he put it together. So -2 and -4 is -6. So you have the same answer on both sides. All he did was add the 6 on the next level to remove it from the equation, so that -3 equals -3.
At this point, you gotta be a professor now, you gotta teach.
I think I'm far, far from that.
No, you gotta be a professor.
Y'all don't get it?
He just explained what he
Yes.
said.
Yeah, he just made an equation, like, he just simplified it.
It is simplified then.
I remember this
Computer
too.
science, it's so basic. And help
How?
me.
I don't know, but.
Come help me, since it's so basic.
Cause otherwise you'd have been trying to do minus, you'd have been adding 2, and then the next level you'd have been adding 4, so to simplify all of that, add them together, cause they're like.
But you could do it the long way.
You can do it many
You
different
wouldn't even
ways.
get the same answer.
But when you end at this final statement here, this final equality, 0 is always 0. 0 is always equal to 0. So if you did everything correctly, it doesn't matter how many steps you put in, what order you do it in. If you did it all correctly and you get something that is always true, then that tells you no matter what values of x you have, both sides will be equal. This is what's called an identity, right? No matter what value of x you have, both sides will be true. Let's say you guess x is 0. In between 0, -3 times 2 will be 6. -2 plus a -4 is -6. You put in 1, both sides will be equal. Put in -2, both sides will be equal. It doesn't matter what values of x you have. If you put it in, both sides will be equal. What we have here is an identity, right? And identity means that both sides are equal, no matter what values the variable are. And sometimes you will get this, sometimes you model the situation and, you may come up with one way to do it and another way to do the model. And you're thinking that they're different models, but they're essentially saying the same thing. Yeah.
So are we supposed to finish the sheet as practice for ourselves?
Now, we started, right? Now, let's look at proportion. This is a type of linear equation, right? This is the most common type that you will see in everyday use. Right.
Should we go?
So we tell them what?
You'll have a little time. You can just start this.
Okay.
Yeah, and
Well, you know what,
continue
can we
with
go over the first one together so we can all be on the same page? How about that?
that. No, you have to know the definition.
Oh,
What is proportion? Basically, it is a statement that two ratios are equal. A ratio compares quantity by division.
We have the same thing, what?
yes. Yes. Yeah. The foreign language paper, yeah.
So a ratio compares quantities by division. Right? So for a group of people containing, let's say, 60 women and 30 men. Right? What is the ratio of women to men? Well, once
60 to 30.
Once you simplify it down, yeah, to 2 to 1. But, you know, what we use to divide 60 by 30. Right? The ratio is 60 over 30. Right? Sorry with the original number. Right? The ratio of women to men is 60 over 30. Right? This is 2 to 1. Right?
So wouldn't it be the ratio of men to women?
Of women to men.
Okay.
Right? Women is 60, men is 30.
Oh.
Right.
I wrote it backwards.
Now, you can write it like this. You can write it as 2 with a colon in between it and 1. Right. And it's read the same, 2 to 1. Alright. Now you know what a ratio is. It's just a comparison of 2 number by division. Alright. Now what is proportion? A proportion is a statement that 2 ratios are equal. Alright. So a proportion is a statement that says 2 ratios are equal. This is an example of a proportion. 60 over 30 is the same as 2 over 1. Now, what we often do is to solve equations involving proportion. Alright. Now, let's say that you have a photo that is 6 inch by 8 inch, and you want to blow up to a large poster with 10 inch on one side. You want to know what the other side should be. That's essentially a proportion problem. An equation involving proportion. So basically, you have, let's say, 8 to 6, and you want the other side to be, let's say, 10. And what should be, the last side should be, that's the x, that's the variable. And you want to find out what x is so that you have blown up the photo. Keeping the proportion the same. Well, you just essentially multiply. If A over B is equal to C over D, then you can cross multiply. Then A times C or A times D is equal to B times C. So by getting rid of the variable in the denominator, you can then just have a simple equation that you can solve.
So it becomes 8x equals 60, and then you divide that by 8.
Yeah, but
Okay.
basically, right, so, starting here, you have 8x is equal to 10 times 6,
60.
and then you have to divide by 8, and you get rid of, the 8 multiplied the x. And what does this give us? What's 60 divided by 8? You can reduce it down to a fraction, right? So what do we have? 4 divided into 60 multiplied. This will give us 15 over 2. So about 7.5 inches, let's say, B side inches, the other side should be about 7.5 inches. All right? Let me fast forward that.
How do you know X is 6?
We don't know X is 6. X is,
No, it's sometimes.
yeah.
Yeah, 6 is because you multiply in
Basically,
the top to the bottom and the bottom to the top.
Basically, how do we get rid of this D? We multiply both sides by D. D cancel. Then how do we get rid of this B? We multiply both sides by B. And B cancel. And you have AB is equal to BC. Or C has B. So that's essentially how you solve proportion. You can practice on this worksheet. We'll go over it next time.
Thank you.
For your evening. Okay, I can let you out 1 minute early.
Oh, yeah, it's 5:10 technically. Yeah, you're right. I forgot.
Just be happy I let you
I
out.
just realized we missing like 3 people.
Oh, the other girl.
Yeah, the other 2 girls and the boy.
You said release the file.
Yes. I don't know what her name is, but that should be her name. Release the files.
That's all I know her as, release the file.
Yeah.
Ursula?
Hmm?
You mean Ursula?
Oh yeah, Ursula.
That's
How
her
could we
name,
forget
yes. How
that?
could I forget that?
Damn, My Little Mermaid.
I like to observe the tiny details, and I know it's gonna sound weird, but I like to know the details.
Okay, what's my name?
We have no fucking clue.
What you mean?
Great.
You
Don't give
lost
nobody
me.
my name.
We'll find out Wednesday in attendance.
I'm not gonna say
Professor, what's his
anything.
name?
Yeah, but
He
he's
already
gonna
knows
look
my
at
name.
you.
He already knows my name. He doesn't even look at me.
He's gonna look at you
He doesn't even look at
and
me when he calls my name.
what's his name?
Don't
That's
tell
what I'm
me.
saying.
I'm gonna wait till you leave.
Don't violate. Don't
I got
violate
$5 right now.
Wait, I got 50
Don't
bucks.
violate my rights. That's my.
Professor, got 50 something
My
bucks.
right.
Hold on.
I'm calling HR. $50, girl. I'll give you my name for that.
She wanna give $50. I could give you better use for that.
150. Bye, Professor.
Hey, how you doing? What's up? I just got out of math class. I know, right? Check me out. Class is, yeah, it's interesting. It's interesting. I got homework. Huh? It's not that I don't like math. It's that sometimes I just think math doesn't like me. And this is dead ass. Deadass. They be like, damn, why the problem fighting against me so hard? What did I do to you? My bad. Damn. But this is all math that I forgot like 15 years ago. Like, yeah, because it's like, damn, it sounds familiar, but I don't remember. It's like, you looking real familiar. I don't, yeah, I'm not bad at it. I be getting like 90s and 85 on my homework. I'm cool with that. If it's 15 questions and I can get at least 12 questions right, I'm okay with that. I'm straight up. Yeah. I just be taking my notes so that way I could be like, I could just go back and be like, I know why he said something about this earlier. And I could look and be like, oh, all right, that's how you're supposed to do it. Because I feel like math is just remembering the formulas to the, yeah. And because I don't really like it sometimes, I don't be wanting to remember it. But it's like, once you remember, you just like, okay, I got it. Like, that's the formula, how to deal with this. Yeah. Have a good day. See you Wednesday. No, this was my last one today. Yeah, my professor was leaving. He probably got another class. Huh? I had English, and I keep fucking up. I woke up late, and when I can't just leave the house, I gotta walk my dog. If I don't walk him, I will come home to shit and somewhere in my house, and I don't. Oh man, and I don't track that. So I had to walk him, and he decided that he wanted to take a while to shit. So I'm just like, whatever. I got to class like an hour late, like 40 minutes late. But when I got there, I had did all the reading, so like I kept raising my hand because I knew all the answers to the fucking questions. So it's like the kids who was already there looking at me like, who is this bitch that she is coming in class late and knowing everything? That girl, that girl. Yeah, and then like she be having us do like a lot of what's the word? Like a lot of group work. So like the two people that we got a new classroom today. So the two people that I was grouped with, it was just like yeah, I don't want to be grouped with them again. It's nothing wrong with them. It's just like they was just talking about other stuff. Oh damn! I was trying to write my name on the board with the chalk, and the chalk broke. Ugh. They was talking about other stuff because they too, I guess they got the similar major, and they was just talking about other stuff that had nothing to do with the class, and I was just looking at them. Mind you, we're in group, so like I'm reading the paragraph that she got up there, and they just looking at me reading it like yeah, okay, well she'll do the work, and it's like no, I'm not. I'm not writing shit on my paper. But we handed in individual sheets, so I was happy for that. Because we put all our names on one paper, and the boy just started writing his answer, didn't confer with us for it. And it's just like, excuse me, who said I agree with your thoughts? Like, so then she comes over and she starts checking it, and she asks him, like, oh, what's the three key principles that talked about in the text? And the boy don't know. He's like, oh, we got one of them. And I pointed at my paper, and she was like, I think you should follow her. She has all three right there. I was just like, do I need to print something? No, I printed it already. So, yeah, I like my classes. I ain't gonna lie. I like my little math teacher. He's like a little, I don't know if he's like, I want to say he's Asian, but I could be being a little racist because I don't know. His last name is Tran. So I don't know, but I like him. He just has like a very monotone voice, so sometimes it sounds but it's not. It's just that that's how he speaks. Like he has no emotion in his voice at all. It's 5:17. I'm gonna go. I mean, it's not annoying, but it's not like my other professors have a little more emotion. But it's like he's just like he's teaching math. Math is not opinion in any way,